Birth of Mercury. Mercury, the smallest planet in the solar system, is the closest to the Sun. Its formation process shares similarities with other terrestrial planets, but also possesses unique characteristics that make it stand out. Formation and early development asterisk. Protoplanetary disk asterisk Mercury formed approximately 4.6 billion years ago from the protoplanetary disk, a cloud of gas and dust surrounding the young Sun. This disk contained the building blocks of all planets in the solar system. Accretion process asterisk during its early formation, dust and rock particles within the disk began to collide and stick together, forming larger bodies called planetesimals. Over time, these planetesimals coalesced into a protoplanet through the process of accretion. Differentiation asterisk as Mercury grew in size, it underwent differentiation, a process where heavier materials, like iron, sank toward the center, forming a dense core, while lighter materials formed the outer layers. Unique characteristics of Mercury's formation asterisk. Large iron core asterisk Mercury has an unusually large iron core, which accounts for about 85% of its radius. This is significantly larger than what is observed in other terrestrial planets like Earth. Scientists hypothesized that Mercury might have originally been larger, but a massive collision with another planetesimal stripped away much of its outer layers, leaving behind a metal-rich core. Limited volatiles asterisk Mercury's proximity to the Sun may have led to the loss of many volatile elements, such as water and gases, during its formation. This process contributed to its thin atmosphere and barren surface. Environment of Mercury. Mercury's environment is harsh and extreme due to its close proximity to the Sun and lack of a substantial atmosphere. Surface conditions asterisk. Temperature extremes asterisk Mercury experiences some of the most extreme temperature fluctuations in the solar system. Daytime temperatures can soar up to 430 degrees Celsius (800 degrees Fahrenheit) due to direct sunlight, while nighttime temperatures can plummet to -180 degrees Celsius (-290 degrees Fahrenheit) because of the lack of an atmosphere to retain heat. Surface features asterisk the planet's surface is heavily cratered, resembling our moon, with features such as vast plains, cliffs, and impact basins. The largest impact crater, the Caloris Basin, spans about 1,550 kilometers, 960 miles, in diameter. Tectonic activity asterisk Mercury has experienced significant tectonic activity in the past, as evidenced by the presence of large cliffs, scarps, formed by the planet cooling and contracting over time. Atmosphere and magnetosphere asterisk. Exosphere asterisk Mercury's atmosphere, called an exosphere, is extremely thin and composed mainly of oxygen, sodium, hydrogen, helium, and potassium. This exosphere is not stable and is constantly being replenished by solar wind and the surface materials. Magnetosphere asterisk despite its small size, Mercury has a surprisingly strong magnetic field, about 1% as strong as Earth's. This magnetosphere interacts with the solar wind, creating magnetic storms and influencing the exosphere. Habitability of Mercury. The conditions on Mercury make it an extremely inhospitable environment for life as we know it. Challenges for habitability asterisk. Temperature extremes asterisk the extreme temperatures alone make it difficult for any known life forms to survive on Mercury. The vast difference between day and night temperatures presents a significant challenge to sustaining any biological processes. Lack of atmosphere asterisk Mercury's thin exosphere does not provide protection from harmful solar radiation or meteoroid impacts. Without a substantial atmosphere, there is also no possibility of liquid water, a key ingredient for life. No liquid water asterisk while there is evidence of water ice in permanently shadowed craters at Mercury's poles, the lack of liquid water on the surface further diminishes the planet's potential for habitability. Radiation asterisk being so close to the Sun, Mercury is bombarded with intense solar radiation. The lack of a thick atmosphere to shield the surface from this radiation poses another significant barrier to life. Potential for future exploration asterisk. Robotic missions asterisk while Mercury itself is unlikely to support life, studying it can provide valuable insights into planetary formation in the early solar system. Missions like NASA's MESSENGER and the European Space Agency's Bepi Colombo are designed to explore Mercury's environment, magnetic field, and surface composition in greater detail. Astrobiological significance asterisk understanding Mercury's formation and evolution helps scientists refine models of planetary habitability, especially for exoplanets in similar environments. Around other stars.